Okay, now starting with the particle physics, we have two types of particles inside the nucleus. We have the protons and neutrons. Outside, we have an electrons, which is moved around the nucleus. The atoms of elements are made of three particles, which are proton, neutron, and electrons. The protons and the neutrons inside the nucleus in the center of the atom, and the electron orbits the nucleus. We will see later that the diameter of a nucleus is about 1 over 10,000 of the diameter of an atom. This number is very important. And we can't use the mass of the proton in kilogram because it's a very high number. Okay, we will use the atomic unit. The atomic mass unit is defined as the unit of the smallest particle inside, and here in A level we will use one atomic unit as 1.66 multiplied by 10 to the negative 27 kilogram. The mass of an electron is very small. It's about 1 over 2000 of one atomic mass unit. Proton has a positive charge. It looks like the electron, but it is positive. Electron is negative charge. Approximate mass of a proton and a neutron is almost the same, which is one atomic mass unit. And for the electron, it is about atomic mass unit divided by 2000. So the electron is the smallest particle till now. We will understand another smaller particle, which is the quarks. We know that the electrons are orbiting the nucleus. Any element can be written like this: Z and A. What are these? Z is the proton number or atomic number, which is the number of protons inside the atom. A is the number of a proton and a neutron inside the nucleus, which is the nucleon number or mass number. A nucleon is the name given to either proton or neutron. So if we have oxygen, 8, 16, we have 8 protons, 16 protons and the neutrons. The number of neutrons is 16 minus 8, which is 8 proton, and 16 is the number of nucleon. This is the symbol for any element. We have to write it in this form. Isotopes. It is the elements which have the same proton number and different nucleon number, like carbon 612, carbon 614, or like hydrogen H11, H12, H13. So these are the isotopes. Okay, they have the same number of proton, different number of nucleon. So they have the same chemical properties, but they have different chemical properties. Now, alpha, beta, and gamma. These becquerel rays come out from inside the nucleus to make it more stable. Not all materials will reject these particles outside, okay? Just the particles which are radioactive materials. And we call these alpha particles, beta particles, and gamma ray. Alpha particle, it consists of 2 protons and 2 neutrons. It looks like the helium atom. The difference between helium atom and alpha, that helium contains 2 protons, 2 2 neutrons and 2 electrons, but alpha contains 2 protons, 2 neutrons, and no electrons. An alpha particle is written as helium-2, 4. Alpha particle is a heavy particle, and the proton number of the nucleus decreases by 2 if alpha getting out from the particle, and the nucleon number decrease by 4, and the neutron number decrease by 2. Let's see. If we have uranium 92 to 34, it gives us alpha or helium 2, 4 plus a new element which is consist of 90 protons and 230 nucleons, which is thorium. No need to remember the name of this element. You just have to understand that the total number of a proton before and after have to be same, and the nucleon number have to be equal as well. How can we detect the alpha particles? We can use the cloud chamber. What is the cloud chamber? It is a glass bottle like this, and we have a cooling unit down, and inside we have alcohol vapor, and in the upper part we put a cloth with alcohol, and we put a light here, and we make this experiment in a dark room. So when we turn the cooling unit on, here we will have a foggy place. So the alpha particle inside, if we have a material here, we can see the track of the alpha particles inside. We can know that if there is an alpha particle or we haven't, but we can't know the amount of alpha particle getting out. And there is an energy getting out as well. So the total mass energy before have to be equal to mass energy after. Mass energy, it means that the mass can be changed to energy, okay, as a value. So we have energy before and energy after. If we add the energy and mass before, it have to be equal to mass and energy after, because of conservation of energy. The atomic mass of the K products is less than the mass of the parent nuclei. What is the parent? Parent is the first element, Za. This is alpha 2, 4 plus, let's say, Y, Z minus 2, and A minus 4. So this is the parent and this is the daughter. If we have another element getting out after this, so this is a granddaughter. Beta particles. In O level, we see one type of beta particles, which is beta -10. Okay? Now we will understand that we have a beta particle with the same features, but it's positively charged, which is a positron. Okay? So we have electrons and positrons. We have elements like carbon 614 and its eject beta, which is -10, plus 7 14, because 14 plus 0 is 14, and 6 minus 1, if you take it to the other side, it's positive, or if you add the proton number after, it's 7 minus 1, which is 6. This is nitrogen, sorry. And whenever you have a beta particle with a negative sign, there is another thing getting out, which is anti-neutrino. So with negative beta, there is an anti-neutrino getting out, and with positron, we have a neutrino. Remember, if we have a negative sign here, we have an anti-neutrino. If we have a positive sign, so it is just a neutrino. Okay, beta particles have a speed of about 99% of the speed of light. Okay, so it's a very high speed. For alpha particle, the speed is about 1% of this value, which is the speed of light. And gamma particle have a speed of light, which is c. Okay. Now, we have here an element, Pb, it's changed to bismuth, and electron, which is beta negative, and antineutrino, and energy as well. There are important differences between the behavior of alpha and beta. In these fields, beta particles may carry negative charge or positive charge, and thus may be deflected in the same direction or opposite direction of the positively charged alpha particle in electric or in magnetic field. So, if we have electric field, positive, negative, and alpha particle pass from here, the alpha particle will deflect to the negative side because it is positively charged. Beta particles, it may deflect towards positive or negative depending on the charge of beta. If it is beta negative, which is electron, it will deflect towards the positive side, but if it is beta positive, which is positron, it will deflect towards the negative side of the electric field. What if we have a magnetic field? Magnetic field, if we have X sign, it means that the magnetic field into the page. Okay, so if we have an alpha particle pass from here using your left hand rule, so the charge moving up, magnetic field into the page, so the alpha particle will deflect to the left. But if we have a negative charge like negative beta, it will deflect to opposite side. But if we have beta positive, it will deflect to the same side as alpha with a different radius. Now, what is the nature of beta particles, positive and negative? Inside the nucleus, there are no electrons. We have just the protons and the neutrons, which is positive and the neutral. What happened inside? We have proton changed to neutron. So, number of a proton decreases by 1 and number of a neutron increases by 1. But the number of nucleon will not change. So here we have a positron ejected outside plus an anti-neutrino. But if we have a neutron, which is changed to proton, we have here negative beta, which is electron, plus anti-neutrino. So the number of protons and the neutrons inside will not change. What happens that the number of a neutron will decrease by 1, but the number of a proton will increase by 1. This is the reason for beta negative and this is the reason of beta positive. Okay, a negative electron and antineutrino are emitted from the nucleus, thus leaves the nucleus with the same number of nucleons as before, but with one extra proton and one fewer neutron. If beta decay positive, the positive electron and the neutrino are emitted from the nucleus. This leaves the nucleus with the same number of nucleons before, but with an extra neutron and one fewer proton. In beta decay, negative electron, a daughter nuclide, is formed with the proton number increased by 1, but the same nucleon number. For gamma radiation, gamma is chargeless, massless, so the number of protons and the neutrons will not change. What happens that the amount of energy before the emission, it's more than the energy after. So we have a nucleus with more energy, so we'll change to another nucleus or the same proton number because this is 0 and 0, but the energy will getting out from the nucleus. What is the amount of energy for one atomic mass unit? One atomic mass unit is 1.66 multiplied by 10 to the negative 27 kilogram. This is the mass. If we use relation E equals mc squared, we can find the energy or the kinetic energy of the particle by a joule unit, okay? But we can multiply the value by 930. If we take one atomic mass unit multiplied by this number, we will have the value in mega electron volt, okay? So we can change the energy to joule by multiply the mass by speed of light squared, or by multiply the amount of atomic mass units by 930. In this way we'll have mega electron volt. How can I change the energy from joule to electron volt? The energy, each electron volt, it's one electron, which is 1.6 times 10 to the power negative 19 coulomb multiplied by volt. Coulomb, which is charge, multiplied by volt, which is voltage, it's equal to energy, and energy measured in joule. According to SI unit, you can change the unit coulomb volt to joule, okay? So if we have 5 electron volt, it's equal to 5 multiplied by charge of electron joule. Now, gamma radiation, it's an electromagnetic spectrum with wavelength between 10 to the negative 11 to negative 13. Since gamma radiation has no charge, its ionizing power is much less than that of either alpha or beta. In gamma emission, no particles are emitted, and there is therefore no change in the proton number or on the nucleon number. Here we can see if we have thorium, which is excited, if gamma emitted, we will have thorium without this star. It's not excited, but the number of protons before have to be equal. Now, this table will give us a knowledge about alpha, beta, and gamma. Alpha consists of 4 atomic mass units because we have 2 protons and 2 neutrons, so we have 4 atomic mass units. The charge of alpha is positive 2 because it's not like helium. Helium have 2 electrons, but alpha lost this electron. It's a helium nucleus with 2 protons and 2 neutrons. Its speed about 0.05 of speed of light. In air, alpha particle can move through few centimeters, from 2 to 8 centimeters only. Its power is very high, and it's affected by photographic film. If you put uranium next to graphic film, okay, you can see a blurring here because of the effect. And it's deflected by electric and magnetic field. Beta also deflects by electric and magnetic field, and there is an effect on the film. Its relative ionizing power is less because most of its energy used to penetrate, so it can penetrate for a few millimeters of aluminum. Alpha can be stopped by a paper. Beta can be stopped by metals or a few millimeters of aluminum. Its speed is about 0.1 of speed of light, 0.99 of speed of light, almost speed of light, and it's negatively charged if it is electron and positively charged if it is positive. Its mass, it's about 1 atomic unit divided by 2000. For gamma, it's massless and chargeless. Its wavelength is short, and its speed is equal to speed of light, like all the electromagnetic radiations. And it can move in a lead for a few centimeters, so its penetration is very high. Relative ionizing power is 1. It's very small because most of its energy used in penetration, not in ionization, and it's not affected by electric or magnetic field because it's chargeless, and it affects the photographic film as well. We can see that alpha deflected or moving up, but beta have a less angle, okay, less angle of deflection because its mass is less depending on the circular motion. What is the radioactive series? Radioactive series starts from a particle and transfer from one particle to another. No need to remember these. Here we have uranium 238 changed to thorium. This thorium changed to another material again. This material changed to uranium, okay, and this uranium back to thorium, and the thorium back to radon, and so on, okay. So this is a decay or a tree of decay. The particle can decay till it's reached an element which can decay more. We can use another device to detect radiation, which is the Geiger-Müller tube. Geiger-Müller tube consists of a thin window of mica, and inside we have a positive wire, and we have a negative outside here, and inside we have an argon gas. If an alpha or beta or gamma radiation get inside, we have ionization inside. So the ionization is, if you have an electron outside the nucleus and take it for infinity, this is ionization. So if the particle or the element lost an electron or gain an electron, this is an ionization. After ionization, the positive particles will move towards the outside case of the Geiger-Müller, and the negative will attract towards the positive rod. So we have a count. If we have another element, 2, 3, 4, and so on, we can't know the type of the radiation, but we can know that we have a detection. Photographic plate. This plate used for doctors who use X-ray or gamma ray in medicine. This device consists of salt, okay, which is not like our salt. This salt will be interact with alpha, beta, and gamma, which is move towards it. After 3 months, we can take this device and see how much the doctor absorb radiation. According to this number, the hospital will give a doctor a sick leave till he finish the amount of energy absorbed by his body. We have a background radiation which is around us every day. Some of the radiation about us, which is a background radiation, come from the cosmic ray, which is about 10% of the ray around us. There is a gamma rays from rock and soil. Okay, some rocks is a radioactive source. The radon and its daughter produced are released into the air following the decay of naturally occurring uranium isotopes found in granite. Medical sources produces 12% of background radiation around us, and this number is increasing every day because the uses of X-ray and the medical uses of radiation is not like before, it's more. The internal sources from the food we eat, liquids we drink, and from the air is about 12%. So these values are almost the same, but as I said, this number, I think it will be grown up with days. Less than 1% from leaks and fault in the nuclear stations. The radiation from the material is a random nature, so you can't guess which particle will give radiation before. If we have 4 particles, maybe particle 1 eject radiation, then 4, then 3, then 1 again if it is have another energy or particle, and then 2. So it's a random nature, okay? And it's spontaneous, okay? Very important to remember spontaneous and random. It is a spontaneous process because it is not affected by any external factors such as temperature of pressure or pressure. If you increase the temperature or increase the pressure, you will not increase the amount of radiation which is getting out from the material. It is spontaneous. Now, we have a famous experiment which is the gold foil, and there is an alpha particles from a source pass through the gold foil. Some of alpha particles pass direct, some of alpha particles deflected, some of alpha particles back, okay? They discovered that the vast majority of alpha particles pass through a foil with very little or no deviation. A small number of particles were deviated through an angle more than 10 degrees. This is the angle. An extremely small number of particles, 1 in 10,000, were deflected through an angle greater than 90, like this, okay, or this. Each 10,000 ray moving forward, 1 or 2 will deflect by this angle. The majority of the mass of the atom is concentrated in a very small volume, which is the center of the atom. Most alpha particles would therefore pass through the foil, okay? This is the nucleus, so most of alpha particles will pass. The center of a nucleus is positively charged, so the particles which is closer, they will deflect by an angle. If we have this is a positive, this will deflect like this. The closer will deflect more, okay? Because positive and positive, it's repel. Only alpha particles that pass very close to the nucleus, almost striking it head on, with experience a large enough repulsion force to cause them deviate from through angles greater than 90, okay? Just the particles which hit the nucleus like this, okay, which is the hit on collagen. Now, some years later, the alpha particle scattering experiment was repeated using alpha particles with higher energies. Some discrepancies between the experimental results and Rutherford's scattering formula were observed. These seemed to be occurring because of the high energy alpha particle were passing very close to the nucleus and were experiencing not only the repulsive electrostatic force but also strong attractive force, which appears to act over only very short range. This becomes known as strong nuclear force. Now, what are the fundamental particles? The fundamental particles, it is the smallest particle inside the nucleus. The positive charge is not the smaller, or the electron charge is not the smaller part in the nucleus. We have smaller than it, okay? The particles in an atom experiences force in order to maintain its structure. The force or gravitational force that acts between all masses. We have a force which is known as a strong force and acts between a nucleus. The force does not seem to have any effect outside the nucleus, and therefore it's considered to be very strong, very short range, a little more than diameter of the nucleus. The strong force acts on a proton and a neutron, but not on electron. So it is the force inside the nucleus. The discovery of antimatters in cosmic radiation supported the theory developed from the special theory of relativity and the quantum theory that all fundamental particles. The numerous types of particles are placed into two main categories. These affected by a strong force are called hadrons, for example, protons and neutrons, and not those affected by a strong force are called leptons, for example, electron and positron. So we have lepton, which is electron and positron, and we have hadrons, which are like protons and neutrons. So inside the nucleus, hadron, outside the nucleus, okay, it is leptons. The total electric charge remains constant even if we have an ejection of any charge. The total number of a nucleus or nucleons normally remain constant. The three types of quarks known are the up and down and strange. So we have U, P, S. The charge of up flavor, it is positive 2/3, down flavor negative 1/3, strange flavor negative 1/3. So if we have a proton, it consists of 2 up and 1 down. 2 up, 2/3, multiplied by 2, which is 4/3. And we have 1 down, which is negative 1/3. The total is 1, which is the proton. If we have a neutron, it consists of 1 up and 2 down, 2/3, and negative 1/3 multiplied by 2, the total is 0. Neutron is a neutral. The strangeness of each is 0, 0, negative 1. You may ask about the strangeness of each. You have to memorize this, okay? Now, if we have lepton like this, we have a neutron, which is changed to proton and electron and antineutrino. A neutron, as mentioned before, it consists of up, down, down. Proton, it consists of up, up, down. You may ask to write this, okay? It's a very easy question. The quark flavor is not conserved as a down quark has changed to an up quark. The reaction cannot be due to the strong force. The beta decay must be due to another force, this force called weak force or weak interaction. So beta decay comes from a weak interaction. Here we can see the up is not changed. This down changed to up and down stayed down, okay? So may the direction change from up to down or down to up, okay? Finally, the total lepton number before a reaction is equal to the total lepton number after reaction. This chapter is very easy. you have to remember it very well, okay? Especially the interactions between particles. Let's see this type of questions. If we have a proton number and a neutron number, and we have an element, let's say uranium, 92, 236. The proton number is 92. And here we have the neutron number, which is 144. If you take this minus this. If we have an alpha decay, so the number of protons decrease by 2, so we have 90 protons, so the particle will move 2 steps to the left, and this number will be 232, because alpha 24. So this number will decrease by 2. The number of neutrons will decrease by 2. So we have 2 steps down. So this is the direction of alpha. But if we have beta decay, we have a decrease in a proton and an increase in a neutron, or increase in a proton and decrease in a neutron. It depends on the beta, if it's a beta positive or beta negative. This is an external question. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.